Hi, now we're going to look at Form 4 Chapter 9 Differentiation, and the subtopic in this chapter is small changes in quantities. In this part, we're going to use this formula which states that sigma y is approximately equals to dy dx multiplies by sigma x. Sigma y here refers to the small changes in quantity y. Sigma x refers to the small changes in the quantity x. So let's take a look at the example. Find the approximate change in the volume of a sphere if its radius decreases from 5 to 4.99 centimeters. So from here we know that the radius decreases. So there are changes to the radius of a sphere. So radius is r. Since there are changes, so we write sigma r. And what are the changes? We always take the later value minus the previous values, which is 4.99 minus 5. And you'll get negative 0.01 centimeter. Negative here means that the radius decreases by 0.01. Question asks us to find the approximate change in the volume. Means the question wants us to find sigma v. In order to find sigma v, it is approximately equals to dv dr times sigma r, according to the formula here. Since sigma r we already have a value, now we only have to find the value of dv dr. In order to find the value of dv dr, first we need to find the relation between v and r. So since v is the volume of a sphere and r is the radius, to relate this we use the formula v equals to 4 over 3 pi r cubed. This is the formula for volume of a sphere. So now we want to find dv dr, so we differentiate v with respect to r. dv dr equals to, so the 3 brings here, you get 4 pi r squared. Now since we are finding the value, means we cannot substitute this into this part. We need to find the actual value. Since pi itself is a constant value, we only need to find the value of r. And r here is given two values. We take the value before any changes. Means we take 5. So 4 pi 5 squared. 5 squared is 25 times 4, you get 100 pi. Then we substitute the values inside. So sigma v approximately equals, here it actually means equals, dv dr here is 100 pi times sigma r is negative 0.01. Hence you get negative pi centimeter cube. And negative here of course means the volume decreases by pi centimeter cube. Question number 2. Given that y equals to 8x squared minus x cubed, find the approximate change in y as x increases from 2 to 2.05. State whether sigma y is an increase or a decrease. So here, find the approximate change in y means we are looking for sigma y. And given that x increases from 2 to 2.05 means sigma x is equals to the new value, the later value minus the previous value, the older value, which is 2.05 minus 2, you get 0.05. Means it increases by 0.05. And we come back to the formula. Sigma y actually is approximately equals to dy dx. Since why we use dy dx? Because it's given the formula here, y is related to x. So we use dy dx multiplies by sigma x. Sigma x, we already have the value here. We only have to find the value for dy dx. So it's very obvious that we need to differentiate this. You get dy dx equals to 8 times 2 is 16x, and this one is 3x squared. We substitute the value of x by using the original value here, which is 2. So 16, 2 squared. Now since we already have a value, sigma y equals to 20 times 0.05, which is equals to 1. Hence, the approximate change in y is as much as 1. Since this is a positive value, it is an increase. Question number 3. It is given that y equals to 5x plus 8 over x. Find in terms of k the approximate change in y when x increases from 2 to 2 plus k, where k is a very small value. So x increases from 2 to 2 plus k. Of course, this means the changes in x is 2 plus k minus 2. So you get k. The question asks us to find the approximate change in y, means we need to find sigma y, which is approximately equals to dy dx, as you are given the relation between y and x multiplied by sigma x. Now, to find dy dx, we differentiate this. And the x here, in order to find the value, we need to substitute a value to the x. And the x, you take the previous value, which is 2. You get negative 8. 2, negative 2. So we substitute the value inside. So sigma y is approximately equals to dy dx, which is 3 times k. So sigma y is equals to 3k. An open tank in the shape of a cuboid has a rectangular base of length 2x meter and width x meter, while its height is 2 meter. So if you try to draw this, you get this. It's an open tank, means here is open. And length is 2x, width x, height is 2. Find the approximate decrease in the total surface area of the tank. Sorry, it should be a tank. If x decreases from 3 to 2.98. So x decreases, sigma x is equals to decrease from 3 to 2.98. So you take the latter value minus the previous value, you get negative 0.02. Since this is an open tank, means it only has 5 surface area. So you try to draw this. The open tank means we can assume that there is no upper part here. Hence, we only have 1, 2, 3 from the side, 4 from the side, and 1 from the base. So there are 5 areas. Okay, 1, 2, 3, this one, 4, and the base 5. The question says find the approximate decrease in the total surface area. So if we let the surface area to be A, means we are looking for sigma A, which is approximately equals to dA over dx times sigma x. So we need to find the relation between A and x first. That's why we need to know how many surfaces are there. Okay, so the total surface A, the total surface is equals to, okay, we have the base. The base here is 2x times x. Then we have this side, which is 2x times 2. And there are 2 of this because one is at the front, one is at the back, so it multiplies 2 again. Plus the 2 at the side, the right hand side and the left hand side. So at the right side here we have x times 2. Since there are 2 sides, we multiply 2 again. Then we try to multiply it. 2 times 2 times 2, 8x plus 4x. So the total surface area is 4x squared plus 12x. In order to find dA dx, we differentiate A with respect to x. Now we substitute negative 0.02 here and 36 to here.